Thank you for downloading and installing the Complex Build software. Complex Build will allow you to build the geometry of your lanthanide complex with full stereochemical control and save the structure as an input file ready to be submitted to other molecular modeling softwares for further calculations, such as MAPAC, LUMPAC, GAMUS, ORCA, Gaussian, and several others. So, without much further ado, let us go ahead. We will help you build your first complex. Please notice that Complex Build will be flashing buttons in red as suggestions to help guide you along the way. To start, you need to choose the metal center. By clicking on the highlighted button, a representation of the periodic table is shown. At present, only lanthanide metals are available. Let us choose, for example, europium. Now, choose trivalent europium by selecting the appropriate oxidation state. +3. Then, click on the OK button. Now that you chose your ionic metal center, it's time to select the ligands, one by one. For that, there are a few simple steps that you must follow to pick each ligand for your complex. First, click on the button Select Ligands. Let us assume, for example, that you want to coordinate ligand BTFA to your complex. Then, you must select the denticity, the number of donor groups in the ligand that will coordinate to the central metal ion. For BTFA, let us select the bidentate denticity. Complex Build now returns a panel listing all bidentate ligands available in its database. Please notice that there are 4 different entries to help you reduce the number of possibilities and find your ligand of interest more quickly. Since BTFA is charged negatively, let us place a -1 in the entry named charge. Now, only bidentate ligands of charge -1 will be shown. Now, place just the letters B and T in the entry named short identifier. Only 2 ligands are now shown, one of them BTFA. Click on BTFA to highlight it. Its structure will be shown here for you to examine it, rotate it, and make sure that it is the ligand you want. We will now add 3 BTFA ligands by clicking 3 times on the highlighted Add button. Now, you want to add a further bipyridine ligand to your complex. In this case, please delete the -1 in the entry named charge because bipyridine is a neutral ligand. Now type BPY on the short identifier entry. Bipyridine now appears. Click on BPY. And then on the Add button. The coordination number now reads as 8, which is correct for a complex with 3 BTFA and 1 bipyridine ligand. Now, please click on the OK button. Your next step is to choose the optimization method for the structure of the complex. For now, please choose the third option, the one called orientation and placement. This optimization requires that you choose a shape for the coordination polyhedron of your complex. So, please click on the Select Shape button. A screen with a number of shapes will appear. Let us assume you want the square antiprism shape of code SAPR8. Click on it, hold and rotate it to examine it further. Are you satisfied that SAPR8 is the shape you want? Let us assume yes. Then, please click on it and then press OK. Now, you must select one of the point groups for your coordination polyhedron. Please click on the point group button and select, in the drop-down list, C1, which, incidentally, is the only one possible for your complex. Notice that complex build will now inform you that there are 56 coordination stereoisomers for that point group. You must now go to the drop-down menu named Permutation and select one of them. Select, for example, this one, and then wait for the geometry optimization to finish. While it builds the structure, you may now minimize the small window. This is the calculated structure of the complex, optimized to serve as a starting geometry for further computational chemistry calculations. The complex can be rotated, zoomed in, or zoomed out, or have its hydrogen bonded to the carbon atoms hidden. Since the coordination polyhedron of this complex is chiral, it's possible to visualize its enantiomer by clicking on the Switch Enantiomers buttons. This complex build structure can now be saved to be used as an initial geometry for more accurate computational chemistry methods, such as those available in MOPAC, LUMPAC, ORCA, GAMUS, or Gaussian. To finish, now click on the single diskette button, named Save a Computational Chemistry File for this stereoisomer. You can now choose the file type to proceed with the molecular modeling of your choice. We hope you will find complex build useful in your scientific and technological investigations. We kindly ask you not to forget to cite the primary complex build article, as citations will help support our work. From the whole complex build team, we wish you all the best and success in your research.